Hey guys, Mr. Johnson again. Today we're going to be looking at solving systems algebraically, and we're going to look at two different techniques to help us to get there. First off, we're going to be looking at solving something by substitution, and then we're also going to be looking at solving a system by elimination. I would recommend understanding how to do both techniques because the expectation is that you will be able to do that. Once again, this is Algebra 1 topics over again, so I'm hoping it'll go relatively smoothly. Let's fire things up. Here we go. Starting off with our example here, which is going to be, you're going to have to be able to solve the system using algebraic methods of your choice often, but you need to be able to be comfortable with both. So that's why we're going to show an example of each of these and then see where we get to from that. Okay, so solving by substitution. Well, when would you use the substitution method? Well, when something is pretty much already isolated for one of the variables. For example, let's take a look at this one here. I've all but isolated the x in this one. Really doesn't take that much work to get me to that next step. And I'm actually going to do that and say, let's say x equals negative 3y plus 5. Now that's pretty good in terms of quickly isolating an x. And now what I'm going to do is I'm going to say, well, guess what? I've got an x in the other equation. So all I do is I pull out the x and I put in something that has the identical value because it says that x is equal to the negative 3y plus 5. So now I'm looking at my function, which is negative 2 times what would be my x minus 4y equals a negative 5. And that's not terribly exciting there. So let's see what we can do about filling things in with the negative 3y plus 5. And now what I need to do is I actually need to distribute this. So I'm going to be looking at negative 2 times negative 3y is 6y. Negative 2 times 5 is negative 10. Whoops. Negative 10. And then minus 4y equals a negative 5. And now what we need to do is isolate things and say, well, I'm looking at 2y equals, let's add 10 to both sides, 5. So I'm going to say y equals 5 halves. Don't freak out, folks. Guess what? You do get fractions occasionally. We'll deal with it. So now I'm going to try and substitute this into something that'll get me an answer relatively quickly. How could I find the other variable? Oh, wait, let's just substitute it back in up there. So I'm now looking at x equals negative 3 times 5 halves plus 5. Okay, cool there. Let's see what we can do about cleaning this up then. So I'm going to be looking at x equals a negative 15 halves, because all I'm doing is multiplying across the top and the bottom there, plus 5. Well, instead of doing 5, how about I just say, instead of 5, it's something in terms of halves, so how about I just write 5 as 10 halves? Oh, that's pretty easy. I'm looking at negative 5 halves. So my x-coordinate is negative 5 halves, and my y-coordinate is 5 halves, so I'm looking at the ordered pair, negative 5 halves, comma, 5 halves. Okay, there's your example of substitution. Let's take a look at one where you're doing something a little bit different. Let's go to elimination. Again, this is something that you have seen before back in Algebra 1, and let's see what we can do. When would you use elimination method? When would it be the best way to do it? Honestly, when you've got something like this where you've got leading coefficients that are not 1, probably just going to fall back on trying to use elimination. Well, let's see what we can do here. What's going to be my system? Well, the first thing I need to do is I need to figure out which variable I want to isolate. And it really doesn't matter. I can choose to get rid of the y or choose to get rid of the x. In this case, I guess I'll just choose the x because they are almost equally difficult. the key thing that you need to do is you need to make sure that your coefficients end up being identical to each other but opposites. So in this case, I'm going to multiply my top equation through by 3 and my bottom equation through by a -2. Another thing I need to briefly mention here is that when I'm distributing the 3, I need to distribute it to all 3 terms, not just the first 2. That's a common error that I'll see, well, very often. So I'm looking at 6x plus 21y equals 12. And then I'm looking at a -6x minus 10y plus equals a +10. All right, and now I'm just going to add straight down. Again, I already set this one up so that they would be opposites of each other and cancel each other out. So I'm now looking at 11y equals 22. And basic math tells me that y is going to be 2 here. Awesome! Now what do? I pick an equation and I substitute that value of y in there. So, I don't know, I'm just taking the first one for no good reason. 2x plus 7 times, and that y value we now know is 2 equals 4. So I'm looking at 2x plus 14 equals 4. Well, subtract 14 from both sides, I'm looking at -10, so x equals a -5. So my ordered pair will be -5, 2. Okay, so far so good. What's next? Well, how about if I've got one where I'm looking at things and I have to figure out whether or not I'm actually going to have multiple solutions or just one solution. Let's take a look at these here. I'm going to look at this and I'm going to say, what the heck, I'll just try and use elimination, and I'm going to say that I want to multiply my top one through by 2. So I'm going to be looking at a -2x plus 2y equals -4. Now my system of equations is this pair here. I don't need to multiply the second one through by anything because I already got it to match. But the problem is when I add down, watch what happens. I get 0, 0. Well, wait a second. If I add these two, I get 0. I add these two, I get 0. So I'm looking at 0 equals to -4. Wait a second. That doesn't work. And I'd say, you're 100% right. When it doesn't work, because 0 is not equal to -4, we know that the answer is going to be no solutions. Okay, next, let's take a look at this one over here. And I'm now going to be saying, well, what do I need to... Ooh, wait, I could multiply this one through pretty easily and say that if I multiply this top one through by, say, a -3, yeah, that's going to work out nicely. -12x, -3 times y is going to be a -3y, and -3 times -6 is -18. And once again, we're back to a situation where I've got a system of equations. I'm going to add down and I get, check this out, 0, 0, and 0. Well, last time I checked, 0 was equal to 0 always. Because 0 always equals 0, we're going to say that we have an infinite number of solutions. Okay, cool on that? Then let's move on. Okay, now let's do a couple where we have actual word problems to play with on this. It says that we've got this situation. Read it and see if you can construct a system of equations based off of what I have been given over in this area here. Do an analysis, come up with your system of equations, and I'll get back to you in 1 second here. Okay, well, let's take a look at the equation I'm going to construct based off of the first situation. It says that I've got 6 lessons, so I'm going to call it 6L, plus it says I've got a one-time fee here, so plus, I'll call it F for fee. That's going to run me $300. And then I can do the exact same thing with this 6 lesson thing. So I'm going to say not 6 lessons, 12 lessons. 12 lessons plus my fee equals $480. Well, I'm going to do elimination, and ooh, I could do this the easy way. How about I just take this top one and multiply it through by -1, because when I add those, I can add down and say that I'm looking at 6L has to equal 180. Sweet. Okay, this will be nice and easy. So my lessons are going to run me $30 a piece. Not too bad. And now let's see what I can do about solving for what my one-time fee is. Well, let's see what we've got here. So let's see what I can do about substituting in. I'll use that top equation, 6L plus F equals 300. Except that it's not L anymore because we already figured out what L was. I'm going to say, let's call it 30 there. Oops, wrote down wrong stuff. Let's fix it, and 30. Okay, so let me see if I can clarify that. 180 plus F equals 300. Okay, let's see what we can do here. Subtract 180 from both sides, and I'm looking at 120. So my lessons are $30 each, and my one-time fee is 120. Awesome. All right, let's finish up with just one more. Okay, let's do the error analysis and see what went wrong here. I'll pull this up so you can see the whole problem and see if you can figure out what went wrong on this. And I'm going to say, let's let you guys freeze it, and then I'll come back and let you know where things went wrong. Okay, I gotta be honest, it's at this point that I'm going to reveal my true colors. I was originally a businessman, so I hate turning everything into X and Y, but I can say, okay, if Y is yogurt and X is my juice box thing, things should line up really, really nicely. Except that we're looking at this case where it says 260 on one juice box. Well, if it's 260 on one juice box and 2 yogurts, I'd agree that this is going to be the equation I'm going to be working with. But wait a second here. It says I've got one juice box. If I've got one juice box, that should be X, and this should be Y. And everything after that is going to be kind of goofed up. All right, folks, you've got some Math Excel to get to, so I'm going to encourage you to do it. Have a lovely one, and we will talk later on.